Hello, my name is Gabrielle Godoy, and today I will present my project on the neuroprotective effects of caffeine and coffee against oxidative stress in shy white cells. So, starting with a little bit of a background, neuroinflammation plays a major role in neurodegenerative disease like Alzheimer's and Parkinson's. And when inflammation becomes chronic, cytokines such as TNF alpha can damage neuron cells and reduce their survival. And to study this, we used the THP1 shy white cells in vitro model. THP1 cells were stimulated with LPS to produce inflammatory conditioner media, and then was applied to differentiated shy white cells. And caffeine and coffee were tested because both contain bioactive compounds with reported anti-inflammatory and antioxidant effects. And our goal was to see whether they could protect neuronal cells and whether they could change the expression of TNF alpha and BDNF. So going to the methodology we used, we first differentiated the shawais with retinoic acid for 6 days in 10 micromolar of retinoic acid, and the media was changed every 48 hours. And then we tested the caffeine toxicity to choose safe concentrations. And then we produced conditioner media from LPS THP1 cells and unstimulated conditioner media as a negative control. So to produce the conditioner media, we grew THP1s. We differentiated them with PMA at 200 nanomolars, and after 48 hours, we stimulated with LPS. However, the unconditional media didn't receive the LPS, was just the PMA. And then we performed two types of treatments. The pre-treatment, where the cells received caffeine or cough before the inflammation of the conditioner media, and the cold treatment, where cells received caffeine or cough at the same time as the conditioner media, always comparing to the unconditional media. And then the cell viability was measured with MTTSA. And then finally, we performed a qPCR to measure TNF alpha and BDNF expression under unconditional media, conditional media, caffeine at 2 millimolars, and coffee at 2.5%. Going to our results. Figure 1C, the graph. You can observe that the neuron length increased significantly, confirming successful neuronal differentiation. And you can also observe figure A and B, how figure B, which is the differentiated chai-wise, has a more elongation format than figure A, which are the non-differentiated chai-wise. Going to figure 2, we are showing the caffeine toxicity. So caffeine was not toxic up to 2.5 millimolars, only 5 millimolar that reduced cell viability. Figure 3 shows the conditioner media inflammation. So the conditioner media reduced, significantly induced chai-wise viability by about 36%, confirming the inflammatory model. And going to figure 4, A and B, figure A shows the pre-treatment where caffeine and cough did not protect the cells. All groups stayed similar to conditioner media. And figure B, the co-treatment, shows that caffeine up to 2 millimolar and coffee protect the cell viability when present during inflammation. However, a high dosed caffeine, such as 2.5 millimolar, became toxic under inflammation. So the MTT results clearly showed that caffeine and coffee can protect neuronal cells, but only when they are present during the inflammatory exposure. So this suggests that their effect depends on the interaction directly with the inflammatory signal. And going to our last figure, you can observe our qPCR results. where shows that TNF alpha and BDNF showed no significant difference between groups. The qPCR was limited by a low RNA concentration, poor prime efficiency, and a non-specific band. So we believe that the mismatch of the expected inflammatory pattern is because of technical issues, especially because of the low RNA concentration. So this project, in summary, successfully established a neuronal inflammatory model and showed that caffeine and coffee can protect shy white cells during inflammatory stress. The gene expression results were inconclusive, and future work should improve RNA quality, redesign primers, and induced additional inflammatory markers. But overall, the findings support the potential of caffeine and coffee as modulators of inflammation-related neuronal damage. I also would like to thank my professors uh, to that guided me through all this project.